In this segment, we're going to explore the oxidation of vicinal dihydroxylated compounds. Wow, that sounds fancy. With periodic acid. HiO4 is periodic acid. And what does periodic acid do? That's a good question. Let's type that out. What does periodic acid do? And the answer is it does the following. And part one. Oh, we got a typo. Oh, I see what's going on. Sorry about this. Technical difficulties. There, move that away. Make it look nice. Purple. It's a three-part thing that it does. One, it cleaves the sigma bond between vicinal dihydroxylated carbons. Cleave the sigma bond between copper bonds, carbons. Okay, what does it do? Also, two, each hydroxyl carbon becomes a carbonyl. Carbonyl. Three, each hydroxyl oxygen loses its H. There's a good summary of all the things that happen. Yes. So, make it look important. Picture's always in the way here. Here we go. Move this. So let's just do one, for example, to start with. I see vicinal hydroxyls here. So in the first thing that happens, I don't know, here. You're going to get a cut. And let's see. Cleaves the sigma. So that sigma's gone. You'll have two units here. So the one on the left looks like this. No, I think I made a mistake on this quiz, and I just want you to fix it before we move on. I forgot to put OHs here and here. So could you please put those on? Similarly, I got the original here. Please put those on for me, and we'll move on from there. And I'm still just doing the one on the right, even though I see another one on, sorry, the one on the, yeah, I see another one on the left now, but we'll deal with that later. So no changes here, here, here. Here's where we got some changes. Follow the instructions. We cleave the carbon-carbon bond. Each hydroxyl carbon becomes a carbonyl. And each hydroxyl, oh, geez, typing is it's going to be a challenge today. Hydroxyl. The carbon loses its H. So that part's done. And we get another product where a similar thing happened. Same things followed on the other side. We've got the carbon there. It's got a bond to O. It's got a pi, and the O lost its H. So for that squiggle, we covered all the parts that we're supposed to cover for the first squiggle. I call that a squiggle. I don't know why. We'll do another squiggle. We'll do the one on the far left here. Why not? Don't forget, this guy's over by himself now. New deal here. That's going to give two products. Follow the same ritual. It's not a ritual until you've done it a few times, I know. There. And there. And you got a new pi, and the H is gone. And you think you're done, don't you? There's something else you got to do. If hydration of an aldehyde or ketone generates new vicinal dihydroxyls, then wow, then that must be done as well, and then do 1, 2, 3 again. If hydration does not yield vicinal dihydroxyls, then don't do it. All right. So we got more going on here. Blue doesn't read very well here. We go. Hot pink, yeah. And still working on the first example. And I'm going to using that pink statement as my guide, I'm only going to hydrate, use the wrong word. I'm going to hydrate one of the 3 carbonyls. Which one is the question? If you hydroxylate this, you'll generate 2 OHs here. They're not vicinal, they're on the same carbon. And it won't have any adjacent carbons with a hydroxyl. Do not hydrate this carbonyl. If you hydrate this carbonyl, you get 2 hydroxyls there, but the important thing is you'll have a hydroxyl vicinal to another hydroxyl. You must do that. This one, don't. There's no possibility for vicinal hydroxyl when it's a CH2 here. So this one stays, this one stays, this one hydroxylates. So I keep using the wrong word. Hydrate. Okay, so I'm gonna the word for hydration here. Hydration. All right. I'm gonna keep all the blues the same here. And hit it with some pink. Hydration puts an H on the O and an OH on the same carbon. Hey, guess why you did it? Because you can now do that. What's that squiggle mean again? This is what the squiggle means. When do we do a squiggle? When you see vicinal carbons with hydroxyls on each one. Okay? Follow the same steps. 1, 2, 3. Ready? It's in red. 1, 2, 3 again. Cut. The pink hydroxyl is not going to change. It was extra. Why do that to me? There we go. Here is the result. Make carbonyl. Get rid of H off the oxygen. Another product. Another product. Here we go. What do we got? We got this. Oh, not following the color codes. Did I copy that wrong? I did. My bad, sorry. You see that I lost this CH2? I'm putting a dot there to make sure I don't lose it this time. Yeah. That could have been a disaster. Okay. Dot carbonyl. Wait, no. I didn't do my cut. Do the steps. I did the cut. There we go. And what's the other? Hey, holy. What else am I supposed to do on the other side? You don't have the H on the O anymore. What do you have? A cut. Each hydroxyl carbon becomes a carbonyl. Good. Carbonyl. And the hydroxyl, where you did the cut, loses its H. Finally. Time to summarize it. You got to read the question carefully. Hard to read it when it's that small, huh? It says, predict the results of the following by indicating the number of aldehydes, ketones, and carboxylic acids are produced. So here's a final product that has aldehyde, ketone, no ketone. Here we go. We have a new aldehyde here. This is new, right here. This is a new aldehyde here as well, and we're not finished with this piece. Don't put an A here yet. This thing's not the end either. We haven't done if hydration of an aldehyde or ketone generates the vicinal dihydroxyl. I think I got to do that first, because if I put hydroxyls on each side by making hydrate, here's the hydration. Don't write the word there. That is a very funny looking H. Hey, guess what you just generated? Vicinal dihydroxyl. Do your cut. What do you get after your cuts? Follow the rules for the cuts. Rules are like, you can't get them wrong. If you do the three things, you get the thing right. Here's the new pi. Here's the new pi. OH. And don't forget you had an old sigma there. Is that right? Oh, I got too many carbons now. So, that's it. OH there. I know, shaky stuff. There we go. Did I follow the parts? Let's see. Cleaves the sigma bond between vicinal dihydroxylated carbon. Cleaves this. That's what that means. Each hydroxyl carbon becomes carbonyl. Each hydroxyl oxygen, that's this one and this one where you did the cut, loses its H. Do not lose these H's. These guys didn't participate. So you got Ca here. That's new. You got Ca here. That's new. And what about the other part of my molecule? I got a ketone here that wasn't here before. This part's clearly not done. So what else we got? We're not done until down here. Here's the rest of these 1, 2, 3, 4 carbons. Here they are. 1, 2, 3, 4. So don't talk to me about this. Don't talk to me about this. There's another carboxylic acid. Here's a new aldehyde. I know you're tempted to call this an aldehyde, but it's not new. It was there from the beginning. I'm pretty sure. Maybe not. No, but we already counted it, right? Don't count it twice. I could erase it here and put it back on the end. I think it just looks better. Yeah, that's an aldehyde, and it was a new one. but I don't want to count it twice. Here it is again. That's the same aldehyde. And now we got to look on the whole sheet. Count up our aldehyde. Of all these things with labels, 1 aldehyde, 2 aldehyde, 3 aldehydes. So we got 3 aldehydes. Pretty sure only 1 ketone. Here it is. Here's the ketone. How many carboxylic acids when we're done? 1, 2, 3. 1, 2, 3. There's the answer. And then I'll give you on the next example, and it might go a little fast and you might not see it until you've practiced a few of these. So you don't have to redraw all the intermediates. There's a way to do it. You do realize every time you did a cut on each side, like twice, once on the left and once on the right of an alcohol, you're going to get a carboxylic acid. Hey guys, if you do 2 cuts from the same carbon, like one to the left and another to the right, it's got to be a carboxylic acid. If you only do 1 cut, you get either an aldehyde or a ketone, depending on if the carbon has an H on it or not. You get aldehydes if the carbon has an H. There's an H here, right? You get a ketone if there's no H on either side. So my next one, the only cut that you're getting on this guy is to the left. Will this become an aldehyde or a ketone? That's your question. It has no H's on this carbon. Please do not say aldehyde. When you do 1 cut, you get either an aldehyde or a ketone. Okay, so you're going to get a ketone. Later on, you're going to generate an aldehyde here, and then you ask yourself the question, if hydration yields a vicinal dihyroxyl, then you better hydrate it, and it will. You're going to get an aldehyde, but it's not a final aldehyde because you can hydrate it and get a OH adjacent to an OH again. So a double cut, what did I say, is going to happen to any carbon that has a cut on each side. Carboxylic acid. Same story here. You're going to make an aldehyde with the first cut, hydrate it to get another hydroxyl on it. Double cut. So that'll be Ca over here. This one is only going to cut, oh no, it's going to cut another time here too. Aldehyde at first, do a hydration, and do this, and you get another Ca. Then this one is going to cut there and then cut here. You're going to get initially a ketone. Ketone can hydroxylate too. It will generate a OH adjacent to another OH. And it's going to become a carboxylic acid because it has a cut on each side. And this one down here is only going to have the 1 cut, and there's H's on here, so at least 1 H is going to get an aldehyde. So there's a summary. And I even gave you a short form. So 1 aldehyde, 1 ketone, 4 CAs, is that right? 1 K, I wrote a K instead of a 1. What's up with that? 1, and then 4 carboxylic acid. So the first example, we showed you step by step what happened. Please do practice exams from old test 4s. And then you'll get more practice so you can get to this one. So you don't have to draw all the intermediate. And the only place you're going to find this question is on the multiple choice. There'll be 1 question in the multiple choice. That's it. Okay. So there you have what you are responsible for per iodic acid. And it looks exactly like this, but it's in the form of a multiple choice. And I'm gonna tell you right now, Here's your answers, you know, one of them's gonna be 1, 1, and 4, and the next one would maybe be 1, 2, and 3. So the total's always 6. Yes, I will have the totals always the same. So the total is gonna tell you the number of cuts. That's another hint you can use if you so choose to, okay? All right, so look at the practice one on the final exam that I gave you the study guide for, and you'll see exactly what I'm looking for. And that's that. And there we go.